Very excited to welcome Luqman here today. Luqman is the Chief Data Officer at 99Co, one of Rocket's hiring partners and supporters. And Luqman is here today to share with us a little bit about database management, a topic that we don't get too deep into in bootcamp, but I thought that would be really relevant for our students and alumni to learn about as well, because all companies and all apps use databases. And while we're building our small apps during bootcamp, it doesn't matter as much, but when we get to production data, it becomes more and more important. So Luqman has some great insights for us today. Luqman has been at 99Co for the last 2 years, if I'm not wrong. Prior to 99Co, Luqman was the Chief Data Officer at Street Sign Technology Group and a Senior Data Scientist at SP Group, Singapore Power. Luqman studied computational biology at NUS and has been in the tech industry for over almost 10 years now. So lots to learn. And I hope that through the session, we'll learn about databases, learn about 99Co. And importantly, I hope we also are able to keep in touch with Luqman, because 99Co is always hiring great software engineers. I'm sure Luqman will share a little bit afterward, and would hope that we can continue to support each other as we go through our careers. Cool. Without further ado, I will hand it over to Luqman. I will also share the Q&A link in the chat so that for those who have questions, you can post there and we can consolidate them afterward.
Great. Thanks,
Great. Off to you.
Yeah, thanks. So Kai asked me to, for permission to share this slide before this particular talk. I'm not too sure how many of you have actually seen, the slides beforehand, before this talk. Any hands? No? Okay. I mean, if you have, the reason why I asked is that if you have gone through and then if you like to ask some questions, then, we can actually just zoom into those slides. Or else I just follow the order of the slides and just present them as is. Okay, let's start. So practical considerations in data and database management, right? So the goal is to share with those just starting out in the software development journey some of the practical considerations that I have learned through, either academia or, from my experience of working with all these multiple companies, all these multiple great companies that I've been in. Right, so I was in NUS as a, how do I say this, as a researcher, as an academic, right? I was supposed to do my PhD, but I left it at that. I didn't complete it, right? Because I can't see myself, doing the same thing for the rest of my life, basically, right? So, and thankful for that kind of decision, because when I experienced different kinds of data in different companies, it's very fulfilling, right? In your life to be able to experience different things, basically, right? And the reason why I have this topic is also because I understand from Kai that you've not gone through this kind of syllabus in depth, right? And by no means this presentation is going to be an in-depth lesson on database as well in production. But what I really want to do is to really just jumpstart your knowledge on data, basically. And once you find work, right, this enables you to have like meaningful technical conversations about it with your colleagues, basically. So that is the whole idea, right, of why these slides were being put out this way, right? So each of the topics and considerations that I put comes at some nights of thinking what could be beneficial, yet not too in-depth, not too in your face kind of thing, right? Something for you to be able to take away from, right? And to be able to have that spark to be able to find out further later on after this session, right? I hope that is clear, right? And you'll be very surprised because some of the things that I'll be talking about, even senior engineers don't know about it, right? So for example, how to make the database faster in terms of the query, right? Some data engineers, some backend engineers actually don't know how to do that, right? So Good news is that we are going to touch on some of these topics, right? So at least, there's a lot of takeaways, practical takeaways for you. Just a little bit about myself, CDO of 99 Group, currently almost 2 years, not 2 years yet. Previously, I was in SRX as a CDO as well. So what happened was that SRX was bought over by 99 Group. So that's how I ended up here, right? And I set up the whole data portfolio in 99 Group, where previously there was none, right? And before that, I was in SP Digital as a data scientist, I2R, A-star, NUS for 4 years, basically, right? I love my time in NUS because I get to learn lots of things. And at that time, there was a goal of some lofty goal, which is to cure gastric cancer, right? But through computational means, basically, and through data. But what I found out was that it's a very difficult problem. So that's why I kind of gave up. Married for 14 years, 4 kids, all boys, right?
Wow. That's a lot of kids.
Yeah, that's why I have to lock my door now.
No.
Yeah, so 99. I'm not too sure. I mean, you guys are Singaporeans, right? I think you might have heard about 99, but if you haven't, then it's if you know Property Guru, we're like the competitors to Property Guru, right? I mean, everybody knows Property Guru. So leading real estate technology company, they operate real estate portals across Southeast Asia. Number 1 in Indonesia, right? Might be surprised. We are number 2 in Singapore. And we are expanding our presence in other Southeast Asian countries around the way. And 300 plus, actually it's 400 plus now, employees across the region. And the goal is really to help 600 million Southeast Asians to find their dream home, right? So you can see that our focus is really on Southeast Asia only, right? And we had the honor of getting the LinkedIn Top Startups Award in Singapore just recently.
Wow.
Right? And yeah, we are hiring. So check out our jobs page.
In case you guys haven't seen, 99Co has sent over the last few quarters, has sent someone every quarter to share with Rocket Academy because they're hiring great software engineers, and yeah, we have Jitcorn currently works there, and other.
We got good engineers coming from Rocket, so
yeah.
That's great. Yeah. Okay, so I'd like to talk about practical considerations about data, right? So some of these topics might seem a bit jumpy, point after point, right? But I'll just summarize it at the end, right? And if you have any questions, just feel free to put it in Pigeonhole. So the first thing when you want to consider when you're talking about data or database is to consider firstly the business needs to design an overall data strategy. Okay, what do I mean by that? When you join a company, you have to first be in tune. I mean, besides being onboarded, right? You have to understand what does your company goals are, right? In which industry do they operate in, and how do they actually make money, right? So I'm just going to give you just an example, right? So for example, marketplace portal, for example, like Property Guru or Amazon, for instance, and high frequency trading software company, tech company, right? So obviously these two needs, the businesses are different, right? So for the marketplace, your job or the company's job is to attract customers to visit and buy from you, and to also attract sellers to set up your shop in your portal itself, right? So when you think about all these things, the data formats that you're working with is, lots of pictures, descriptions of products. You need to store user information. You need to store blog articles, things like that, right? Whatever you think about Amazon, when you think about Shopee, think about those kind of data formats, those data that you need to store, right? And when we talk about marketplace as well, it is hardly that you need to have streaming kind of data. It's usually batch data. And batch data usually means that, well, it's not streamed, but, you kind of push it or you kind of retrieve it in a batch kind of way, right? That means send, and then you just retrieve. That's batch. So it is not continually sending, continually retrieving, right? And hence, the data storage and retrieval speeds for that marketplace just needs to be of an acceptable latency to consumers. Now, I put an asterisk over there. Sorry, do you guys know what latency is? You guys know what it is, right? Yeah. Okay, so I put an asterisk over there, and this is a homework for you to Google on this article about every 100 milliseconds of latency costs Amazon 1% in sales, right? So what you may term as acceptable might not be acceptable to Amazon itself, right? So context matters in this case, right? And hence, right, for the marketplace, the typical data kind of databases that you need are probably relational, document-based, in-memory analytical data warehouses, right? As opposed to high-frequency trading, right, the business needs are very different from marketplace, right? You need to have data. You need to have data to make lightning-fast decisions to either enter or exit the market, right? And the data format are just trading data, but coming in at nano or picosecond, right, from different markets itself. Right, it's extremely fast, right? There's this company called Grasshopper, which is I'm not too sure whether you heard about it, right? It's kind of an innocuous name, right? Grasshopper. What sort of name is that? But actually, a very successful trading company in Singapore, right? HFT company in Singapore, right? I have the honor of knowing the CEO and some of my colleagues from there. And hence the data is actually a streaming kind of data as opposed to kind of batch kind of data. And if you're talking about fast, quick data, you're talking about data that's coming in very small packages, right? Where only the most critical information are actually derived inside that data. However, that doesn't mean that you're only working with small kinds of data. Usually, there's a kind of parallel stream, right, where you can also have larger data coming in as well. And this is usually, they usually use this to just do analysis, right? So this can actually be sitting in a much slower database, right? And you can use like the after market hours to actually just do analysis on it, right? So consider business needs. Next, consider using a managed database service, right? So if you don't know what a managed database service is, you think about AWS, you think about GCP, they have a service for you to set up your own database from their portals, right? So for example, Amazon has the RDS, relational database service, right? And GCP has the Cloud SQL as well. When you're talking about last 10 years ago, a lot of people, including myself, were actually setting up our own database service, right? So we have to buy a server in a box, metal box, set up the server itself, optimize it, and then you install our database service inside that particular box, right? But in today's case, there's very little reason not to be using a managed database service, right? As the cost is very, very affordable, right? And unless you're in these very extreme cases in your company, right? Your data is super sensitive. So MinDev comes to mind, right? So for MinDev and also for Singapore Power, I used to be in Singapore Power, right? We have some sort of like a hybrid architecture, hybrid cloud, where some of the cloud is actually sitting on the public space and the other cloud is sitting in our own data center, right? And those very sensitive information is not going to go to the public cloud at all, right? So that database, you need to have your own database sitting in your own premise, right? And you require very bespoke resources. So, for the managed database service, right, they usually have options that caters for 90% of the cases, basically. However, for the 10% of the cases, for example, you need very high memory or storage, they don't offer that. And, if you have that kind of really bespoke services, that means you're doing something really special, right? So you need to set it up yourself, right? Number 3, you can afford one or many DBAs to tune your database for extreme performance, right? And this is very pertinent for those companies which value latency, which value time, basically, right? So they continually tune their database for extreme performance, right? Number 4, when data and operations grow too big, right, that is really just more cost effective to host the data yourself. And this is what happened to a lot of, big tech startup, big tech, companies like Facebook, for example, right? They used to be on AWS, right? And then they grow so big that, it doesn't make sense for them to actually be paying AWS. It's actually much cheaper for them to actually, co-locate all their data and services in their own data center. That's how big they become, right? So the economies of scale is actually there, right? Yeah. So unless you're in these very extreme cases, go for managed database service. Data types and goals. Consider data types and goals when choosing a database stack, right? This is related to point number 1, right? Where you have to consider your business needs. right? So once you consider business needs, what are the kinds of data that your business actually is operating in, right? Then you go for these 5 options, right? So you have the relational database, document, key value, graph, and column. These are the most common kinds of databases that is out there, right? So relational database, what is it? It's a collection of data items which is just organized in terms of rows and columns, just like your Excel sheet, right? But what's different about it is that you can query it using SQL, and then it can come in a form of many tables. You guys know about it, right? And for each table, they can actually join with another table using a primary key and foreign key, right? So the broad use cases, relational database service has been around for decades, right? This is the first database that actually came up, and so many broad use cases. But one of which is that if you have a definitive schema structure to your data and has a definitive relationship between each one of them, then by all means that will be your default database to be using, right? And it fits most use cases for transactional ops. Transactional ops, what I mean by transactional operations over here is your CRUD, right? Your create, what is our remove? Is it remove? I can't remember.
Read. Oh, great. Retrieve.
Create, read, update, and delete, basically. Thanks. Right. So that is transactional ops, right? So you can't go wrong starting out with a relational database, and some of the very good examples, famous examples, MySQL and Postgres. Document-based databases is a collection of JSON-like documents. So they're stored as in one document. So one document is like one JSON, one big JSON, and data that's usually related to each other are usually found in the same document, right? So as opposed to relational database where you can find some information here and there, usually for document-based database, you try to co-locate it into one document. So when do you use it? Broad use case, when data schema needs to be flexible, right? We'll go through one example later on, or just when you're lazy to do joins, right? Just use document based database, right? And it's also suited for transactional ops as well. One example is MongoDB. Key value is also like a dictionary as well, something like JSON dictionary or Java hash tables, right? In which you have like a key, right? And then you just call this key and then you get the value that's returned to you, right? Very simple, right? No structure at all, right? And hence its use case is actually very simple. It's just to store blobs. Blobs is like your binaries, for example, your PDFs, your Word documents, or your pictures, right? So one of the examples is GCP Cloud Storage or AWS S3, right? So all you need to do is just to store your binary inside AWS S3, and S3 will give you the link to how to access your binary, right? So that is an example of a key value database, right? Okay, might not think of it as a database, but it is actually a database, right? So besides that, caching of temporary data in memory. So for example, you build websites, you want to store the sessions for each user coming to your website and then pass on that session when he visits other pages, right? You use an in-memory database to store this session for the user. Not great for transactional ops, right? Not suited at all, right? Okay, so as some examples is Redis. This is an in-memory database, AWS S3 and cloud storage. Graph is very interesting. Graph databases, very new as well. I think the technology just happened like just a few years back. Still no good take-up rate yet. However, it is good for analyzing data with many relationships, right? So you have a collection of data. Do you guys know the concept of graphs? A graph only has two things, right? You have nodes and you have edges, right? Edges are things that connects two or many nodes together, basically, right? So imagine one node is a person, right? Kai, for instance, right? And then there's another node, Luqman, right? And then there's an edge that connects these two, and which is, this top, for instance, right? That is the relationship between us, right? And if you imagine, a lot of people populating these particular graphs, for instance, right? For example, you guys over here, then you can do many things to pick up, for example, second degree relationships, third degree relationships, for example, very easily. Okay. right? So which is something that relational database is very hard to do in relational databases, right? You know that 6 degrees of separation thing, right? You can actually test it out using a graph database. Okay, so the famous technology that is company that is building up graph database is actually Neo4j, right? But again, graph database haven't found really a production kind of case, for transactional cases, right? So it's mainly used just for analysis for now, right? Lastly, the column-based database, right? It's the same as the relational one, exactly the same, right? You're talking about rows and columns, right? It's the same as relational, okay? But what is different in this case is that you store the data in columns rather than rows, okay? So when you talk about your Excel sheet, right, you store things in rows, right? Right. One datum, okay, one piece of data, right, is one row, right? In columnar databases, it is stored as a column rather than a row, and it is much faster. I would not use the word faster. It is much more efficient to be stored this way. I'll give you an example later on. Right, but then it's not suitable for transactional ops, but it's mainly very suited for analysis of large data. Okay, so a lot of technologies for this, right? So there's BigQuery, RDS, and Cassandra. Now, by no means that this is actually an exhaustive list, right? There are so many other database technology out there, right? But these are the ones which are, quite common or up and coming, basically, that I picked up. Right. So quick examples for relational and column. What's the difference? So over here on the green picture, relational databases, quickly, you have student table, okay, you have courses table, and then you have an intermediary student courses table, right, that matches that matches these two pieces of information together, right? So you can see the relationship, which is the student taking the course, right? Now, on the right, okay, there's another example also, right? And this is an example that highlights the difference between a relational database and a column-based database, right? So when you store, for example, this particular table, right? A country US has product alpha with 3,000 in sales, right? That is one datum, right? And how it is stored in a normal relational database is how you see in the row store. Right. So in one particular row, there's US alpha 3000, US beta 1250, and so on and so forth. However, in the column store, you can see that the country is put together, right? But the relative position of it follows the rows, right? Now, why do we want to do this? So for example, right, if you want to know how many countries products are there in the table, right? All you need to do is just to pick up this particular column only, right? And then you do your aggregation. That is much faster than going through the rows one by one. Can you see that? And pick out and fish out the information only for that particular country, right? And so this is why it is much more efficient during analysis, because during analysis, what we do is that we always want to see one column aggregation at a time, right? That is what we usually do, right? Give me the average number of sales, for example. And then you have the sales cost column, right? If these are all co-located in one column store, it is much faster to actually take them out, right? And this is the reason why column store databases are very good for analysis, much more than the row ones, than the relational database ones. Okay, this example of a document-based database, like I mentioned, the schema is very flexible, right? So, at the background you have Tom Johnson, right? So Tom Johnson, you have a lot of information that you want to store about him, right, including his social media accounts. Sammy Shark doesn't have a social media account, right? And this is the only thing that you have from him, right? But that in the relational database format, right, this is you have a lot of trouble storing this kind of information, right? But in a document-based format where the schema is very flexible, you won't have this issue. However, since the schema, you have to control the schema yourself, there are issues where you have to take note of the data type for each particular parameter, for instance. So for example, the first name, department over there, right? Department is a list, correct? But if you see Tom Johnson, department is a list, finance, and then something else. I don't know what it is. However, in Semi Shark, it's actually a string, right? And for Tom Johnson, it is department is a list. Now, if you were to be coding this, right, you have a lot of trouble, right? Because if you want to extract department from your collection of documents, right, you have to write if-else statements, right, just to extract the information, right? Because the data type is not just one type, which is list, but it's a collection of list and string, right? So the ideal way is, when you set up this kind of schema, right, you have to talk to your guys and say that, look, department has to be a list. If not, we're going to have a lot of trouble. So you have to control the schema yourself. And it gets worse because sometimes some people, they misspell the column names wrongly. So for example, email becomes email, for instance, right? The I and E got switched. And, that's your schema will be, will be very messy, basically. Because now when you want to extract email, you also have to account for the misspellings as well, right? Now, this wouldn't happen in a structured relational database, right? So just some caveats when you use document-based database over here. Graph database.
Maybe you can fast forward a bit to a section on maybe advice on how we would design databases. Let's say, I think most of us use relational databases during bootcamp. Yeah. And so we have to come up with schema. We have exercises for designing databases for different types of apps, whether it's marketplaces or other kinds of CRUD apps or other apps that we build. I know that you had prepared some points on, I just want to make sure we have enough time for the Q&A as well. And I know you had prepared some points on how to design databases. And so maybe that would be helpful for students to hear.
Right. Do you want me to go through it now or?
I think we can fast forward. Yeah.
Yeah, actually, there isn't really a magic rule. So I actually covered it over here. So let's say you're just starting out, right? You don't know, let's say you need to build a new feature, for example, right? And you sort of want to get it out quickly. You don't really want to study the kinds of data that's coming in, for instance. Right? That's where you use a document-based database, right? So that's a general rule. Right. However,
if you're just prototyping, you just want to get something out as fast as possible.
Right.
Just do
get something out quickly. Document-based database. As you go over time, right? Over time, when you are well aware of the schema that you need, right? You can still stick with the document-based database. There's no issue. However, if you want to get a much more, actually, I'm a bit biased over here, but I prefer relational databases much more, right? Because they are much more powerful in terms of aggregation, in terms of, relational thing is a very powerful tool, right? Document-based databases don't really have a strong concept of relations, right, between documents itself, right? So if you value that kind of feature, right, then I suggest after you are done with as you get your document-based database running, you sort of get used to the schema. You can design your own schema after that, right? And then you can port your data over, right? However, you're free to actually still stick with the document-based database, right? That's no issue as well. Especially if, let's say, you find out that your schema keeps evolving, over time, right? That's where you just stick to the document-based database. Now, how do you analyze data coming from document-based database as a form of in a relational kind of way? There's actually a way to do that. And that way is to port the data into a data warehouse itself. And that's where you have the power of flexible schema that comes with document-based database and the relational aspect of it, right? Coming from the
column. So we can get a hybrid, basically.
Hybrid, yeah.
Both.
Right. And usually people do that because they want to, people do that because they want to analyze what's inside their document-based database. Yeah. Right. MongoDB query is very painful. I'm not too sure whether you guys have used it before, but it's to me.
Some have used, I think some graduates have used Firebase. Actually, about half the students here haven't even touched SQL before. any databases yet because they're just started up
All
bootcamp. So they might be some of this stuff might be a bit over their heads right now.
Yeah. So great. Perfect time to consider using wisdom, of course, when choosing a database technology. Right. So when you're trying to learn a database for the first time, for instance, right, go with whatever the professional developers are already using. So for example, the first place over here, MySQL. Second is Postgres, SQLite, all the way. Right. I would recommend the first three. No, sorry, I would recommend Postgres and SQLite and MongoDB, basically. Right. The reason why not MySQL is because, well, you can as well, because Postgres and MySQL is almost the same, very similar, right? But to me, Postgres is much more feature rich. And then you avoid the dreaded, basically, right? So these are actually coming from Stack Overflow surveys. The latest one is 2021, right? Very, very insightful. But however, the results don't really change that much year after year, right? So it's unless it's something cool that just came out, right? I would suggest that you avoid the dreaded ones which are below, right? Okay.
Yeah. Would you have any tips for, let's say we were designing a schema, like, because we build many apps during our course, and even beyond our course, we're going to be working at companies building apps. Would you have any tips for how best to come up with a schema that makes sense for our application needs?
Yeah, that's really difficult because different companies, different situations, different kinds of data, requires different kinds of schema, basically, right? So, but if you want to talk about schema, maybe I just fast forward to this, right?
Yeah.
Well, this is important as well. Okay, hold on. So we'll talk about data normalization first. Right? So
what is this?
Right. So data normalization, well, the description is there. It's a process of structuring a database to reduce repeated occurrence of data. That means to reduce redundancy. Okay. Why is this important? I'll get back to that later. Oh, sorry, it's already there. So if you reduce redundancy, you increase the data correctness and integrity. Okay. Now, how does it do that? So for example, right, this particular example, you might think that, there's nothing wrong with this way of storing data, right? So for example, roll number 401, this is your ID, right? 401, you have a student name over here, Akon, okay? And then you have, actually, I'm sorry, I didn't attribute the link, I'm very sorry about that, but I got it from some website. And then, you have a branch over there, CSE, and then you have the HOD of the branch, Mr. X, and Mr. X telephone number is there, right? So what's wrong with this, right? Well, the data is not normalized. So imagine if you have data that is not normalized, you can have these three kinds of anomalies. So for example, insertion anomaly. If you want to insert a new student, for example, right, you have to put in the rest of the other information. Right. So for example, if I have another student called Luqman, for example, right, roll number 405, right, if he doesn't have a branch, you need to leave those three branch, HOD, and office style empty, right? Okay, doesn't make sense, right? And branch information is repeated every time a student shares the information. So for example, if I come in, right, I belong to the CSE branch, I have to fill out the whole information of the branch, HOD, and office style again. Right? So you can see that there's redundancy over there. And why is redundancy not valued, right? In this kind of schema is because you have the update anomaly as well. So if let's say the Mr. X phone number has changed, you have to change all the rows, right, that contains Mr. X's number, right? And if you forgot to update just one row, for instance, then that introduces errors, right, in the database itself. And then you have a deletion anomaly as well. So deletion anomaly is that if, let's say, Akon, for example, right, the first row, he has graduated very early, right? So you need to delete him from that database, right? Then you need to delete the CSE branch and HOD as well, right? And let's say he's the only student left in this table, right? If you delete Akon, you'll be deleting the whole branch, HOD, and office style as well, and you lose that information, right? So this is what happens when your data is not normalized. Now, when I was in uni, I learned about database. I can't remember the course name, but the whole 2 modules is just databases, right? And We learn about first normal form, second normal forms, third normal forms, all the way until the boys' court normal form and the fifth normal form. These are the kinds of redundancy removal methods, right, for a schema, which in a company, they hardly use this at all, right? So this is more to the realm of the academic, but it has some good pointers that you can bring up, to your working life as well, right? So I'm just going to give you a very quick example, right? I'm not going to go through the whole, normal forms over here, but for example, first normal form, right? It has certain rules. There's 4 rules over here, right? It should only have single atomic valued attributes and columns. Single atomic value means that if you see the subject over here, there's OS, comma, CN. That is not how you should be storing your data for first normal form. You should be, putting it into another row, right? And the reason is because, again, with regards to the deletion anomaly, for instance, right? If you want to delete CN, for instance, then you need to delete the whole row and probably you need to reinsert row 101 back, this time with only the OS, right? Okay, so that just gives you a preview of how normal form rules actually work, right?
Awesome.
Okay, again, value stored in a column should be of the same domain, same type. Or if it's a string for this column, it has to be a string all the way, right?
Yeah.
Or else you bump into the issue of that MongoDB example that I told you, right? In which the department is both a list and a string.
Yeah.
Your back-end codes is going to be very messy. If let's say you have to take into account different kinds of different types of data just on the same column, right? Doesn't make sense, right? And all the columns in the table should have unique names, right? This is pretty, makes sense, right? Or else the database doesn't know which column you're referring to, right? And the order in which the data is stored does not matter. Okay, this one is just a given, right? So that's first normal form. And then when you go upgrade to the second normal form, the requirement is that the first table should be first normal form. And this is how it is, you go up the list. The third normal form, one of the rules is that it has to be second normal form, right? The fourth normal form is that it has to be a third normal form, right? And which we just cascades down, basically, right? And there should be no partial dependency. Now, if let's say I give you a table, the top right one, score ID, student ID, subject ID, marks, and teacher, for example, right? In which we're just storing the marks that the student gets, for the subject, right? And then you're storing the teacher over here as well. What could be wrong, right? Okay, so this actually is, it conforms to first normal form already. Okay, so it conforms to it already. However, second normal form requires that there is no partial dependency. What do I mean by that? Okay, now, in this table I'm showing you, right, what is the minimum candidate key? Have you guys learned about candidate keys?
No.
Okay, it's like what 2 columns or what column do you use besides score ID? Let's not count the score ID. Okay, student ID, subject ID, marks, and teacher. And remember, these are the marks. These are the marks that the student score for the exam, right? If I want to ask you which column or groups of columns it can be used to identify the marks that the student gets for a particular subject, your answer would be student ID and subject ID, right? Because if I were to say student ID, then I don't know which subject am I supposed to take up for, right? Right?
Yeah.
If I give you subject ID, then you don't know which student I'm referring to, right? So student ID and subject ID is the candidate key. That means it uniquely retrieves that particular information. Right? That's the minimal set of keys, student ID and subject.
Yeah.
Now, so marks is dependent on student ID and subject.
Yeah.
Okay. Teacher, it doesn't make sense for a teacher column to be reliant on student ID and subject ID. Right? It should only be reliant on only the subject ID, right? Because the subject ID would have one teacher, right?
Yeah.
So that is a partial dependency, right? So a dependency, there's two columns that makes up the dependence, the thing that every column depends on.
Yeah.
However, the teacher by right is only dependent on only the subject, not the student ID.
Yeah.
So that is a partial dependency. So how do you solve it? How do you solve this is to break it up. Break up these 2 tables into purely the subject and the student's scores without the teacher. right? So that is the second normal form, and hence you have reached. Yeah. So there's a lot more. I'm just going to give you only two because really this is a very deep topic basically, right? And you have like 5 normal forms, right? So if you're really interested, Google up on normal forms of databases, and that should actually guide you in how you should actually, come up with a schema for your relational databases.
That's actually super helpful because we spend a lot of time building apps during our courses, and we do some quote unquote commonsensical database design, which I think many of us have thought of some of the principles in first and second and other normal forms. But for those who are curious, how much thought actually goes into designing databases, especially when we need performance, these are the kinds of parameters that we will think about, and these are the kinds of frameworks that people will use when thinking about how to design a database for, let's say you're working at a company that handles large data in the future.
To be honest with you, senior engineers, they don't really think about normal forms, basically. They just base it on experience. Okay, I need to split this. If not, then it becomes an anomaly. Let's say I want to change things, it becomes very rigid, for example, right? But what I'm sharing with you is are the proper terms that we use in academia. We describe, how we actually reduce the redundancy, right? Okay, so, but I'm just giving you something which is, which just reverses what I say, okay? So in practice, you need redundancy, or at least some little bit of it, right? Because you need to have faster data access. Now, what happens if you have a perfect schema that doesn't have any redundancy at all? The after effect of this is that you're going to have a lot of tables. And if you want to query something that the first table would need something from the last table, you have to join many tables together, right? Okay, and that creates a lot of cost in terms of performance for your database. So to remove redundancy is both an art and a science, actually. So, the kind of how much redundancy to have in a database is both an art and a science. Okay, I'm not saying that you should have total, no redundancy at all, right? That would be great in theory, right? But in practice, it's very bad on performance. Okay. However, these are the kinds of things which I can't teach you, which you have to rely on experience to see.
That's part 2 after we become experienced engineers and we've had some more experience doing this under our belt.
Right. Okay.
Awesome. I think I'm gonna fast forward to Q&A. Is that okay, Luqman?
Awesome.
That was great.
Yeah. I think this is important as well. Transactions as unit of work. Maybe just a very quick one. Is it okay, Kai? So
maybe a minute. Yeah.
Yeah. Sure.
Okay.
So let's say you have you want to write a query, right? A sends $15 to B. Okay. So what happens is that you write the first SQL statement: update customer set balance equals to balance plus 15, where customer name is B. Okay. However, A only has $10. Right? So when you do the update customer set balance, where balance minus 15 for customer A, you will fall into a constraint error if you set a constraint for the column anyway. Okay. Now, what happened in this case is that you already send, if you're a bank and you have this kind of anomaly, right? You're gonna have a lot of trouble explaining why B profits $15 and A, without taking any money away from A, right? Okay. So this is where transaction scope comes in, right? And this is super important as well. So you need to consider transactions as a unit of work. So in your database, especially for relational database, you can start a transaction, okay? And if you run that same SQL to SQL again, okay? And if you hit an error, right, it will not commit anything to your database.
Nice.
Okay, the whole transaction failed, B does not receive any $15, right? So transaction as unit of work is very important, especially if you work in banks.
Yeah, we don't cover transactions in Rocket's Bootcamp, but again, this is one of those topics for people who are keen to learn more about databases and how databases are used in practice. That's one of the key topics, especially in finance, as Luqman mentioned.
Yeah.
Awesome.
Okay.
I'm going to jump ahead to.
Sure.
Okay, I'm going to jump ahead to Q&A because there are a bunch of student questions. I also want to make sure that we are able to talk about some of the stuff that we have top mind. But a few students actually in the past have asked about computational biology, and so or at least biotech companies in Singapore. And I was just wondering if you had any insights on that for those students who had asked about it. Like what kind of opportunities are there for people who are interested to get into the biotech field for software engineering?
I mean, it really depends, because even biotech companies itself, it depends on which departments you work in, right? So a lot of departments actually rely on tech quite a lot, but their scope of work might be very different from each other, right? So if let's say, I was working with research, in research, for example, in gastric cancer, right? So what usually entails is that, every day what I do is I get some data sets. I continue to work. Basically, I got a project, and then some prof would say that, hey, Luqman, I need to get some insights. He just be very generic, right? Without giving me any sort of very specific instructions. He said, find some insights. We have cancer patient data and we have normal data, right? So where are the aberrations? Where are the differences between these two genomes? For instance, right?
So it's more like research, data analytics, the opportunities that you see, less of like product tech companies in biotech.
Yeah, and the deliverables are also very different, right? So for my case, last time when I was in biology, the deliverable has to be in the form of a paper, some new insights that you can share with the world, basically. And once you have that, then they'll fly you around the world, just to give conferences on what you found. So that's pretty nice as well, right? So the airfare is taken care of.
Thanks for sharing.
But the industry, it's more on dollars and cents, right? Business has to survive. Right. So it's very different.
All right.
Yeah,
that was just a tangent, because I know that some students have asked about biotech before, and they've asked us to find biotech speakers, but actually there aren't that many biotech companies. Most of them, or even in the ones in healthcare, are more consumer tech. Less of
you want to do some biotech stuff, especially in terms of research, you have to have domain knowledge in biology. You can't, you can't wing it, basically.
Chuan-Xin has a great question. So Chuan-Xin has a question about organizations that use multiple schemas and database technologies across the product suite. Is it even recommended? It sounds like Luqman was saying, hey, based on different needs at various companies, they use different databases for different needs, different products. Chuan-Xin, do you want to elaborate on that question?
Okay, it's mainly I have had conversations with tech leads of certain e-commerce companies, and they told me that they maybe use certain database tech for different parts of their product. Like for instance, MySQL for user management, and then another database tech for transactions, and then another database tech just to archive previous transactions. So usually, what is the thought process involved when it comes to involving different schemas or database tech in your product suites? And is it even recommended or common in the industry to do that?
It's very common. So, like I mentioned over here inside this example, the first example over here, right? So even in the marketplace itself, you can see that the typical databases needed are all these, right? So a lot of companies actually employ all of them, right? And it's really due to the needs of the company in terms of the problems that they want to solve, rather than, okay, I'm a company, I should only be using technology A. That's not what happens, right? It's very problem specific driven, right? In terms of the selection of the technology itself. Yeah, so to answer your question, it's very, very common, basically, to have a lot of databases in one company doing different things and storing different things.
Chuan-Xin, does that answer your question?
Yeah, thanks so much.
Awesome.
Yeah, wow.
Ray has a question about work-life balance. I think it's around your family, you being married for 16 years and having 4 kids. Was it challenging balancing your career in IT, in tech with your family? Is it more challenging than people who are not working in tech? Is being someone in tech and a family harder than not being in tech? Ray, did you have anything to add to that?
Yeah, because when Luqman, you mentioned your career in your previous roles, it all seems to be what we're hearing from popular social media and word on the street, that these are the roles that actually one of the common things out here are like long hours, and like I think it's in terms of like high commitment, and plus in a sense where it's a role where the higher management relies on data data analysis, data scientists, and they all come to you for things, and then you have to provide the things they need to provide have to have good consistency and good integrity. So I think there's that level of stress there, but the main thing is that work-life balance. And you mentioned, wow, like married 14 years and 4 kids. So yeah, what was it like? Really interested to know, because the people from my age group I've heard from basically either singles or like no kids. Yeah,
How old are you, by the way?
I'm 40. Yeah,
Okay, okay. You're not married yet with kids?
no.
Okay, okay.
Yeah.
Just something I want to share as well. I got married when I was an undergrad in NUS. I was in year 4 doing my honors year, right? And then, because I have a business at that time, so I was earning. But a lot of my friends, even my professors, I was doing my honors year project at the time. I invited my prof to my wedding, and then he was like, "What are you doing, man?" So, and true enough, after I got married, my grades actually slipped. But thank God I did quite okay, actually. It's, so what I'm trying to say is that even for studies, right, even when I got married, when I was still studying, you need to balance your life, basically, right? You might think that studying is much easier to balance your life compared to when I was working, but there's a lot of pressure that comes with it as well, right? Because I need to show my in-laws that I'm actually providing for my wife as well, at the same time study. So I had to both work and study at the same time, right? So juggling is, I guess I trained myself to juggle quite early in life, basically. So having 4 kids and juggling work is somewhat like second nature, I suppose. However, I don't want to give like my own experience. I think I have friends who are also married with kids as well in the tech industry, right? I just want to say this: in any industry or in any company, there are ups and downs, right? There are times that you need to stay back and make sure that your numbers are right, especially when you're doing data analysis. But I don't think it's that common, right? There's some cases where I need to stay back very long hours to do that. But that's not the norm in the tech industry. Unless you are in Alibaba, for instance, I don't know. There's this 9966 culture, right? That's pretty painful from what I heard from some of my friends. And also, if you're in finance as well, I do have friends and relatives who work in banks, as in tech as well, especially data analysis and software engineering roles. And what they have to do is that they have to stay up when the markets are open, overseas markets are open, right? And that is in ungodly hours, like for example, 12 to 5 a.m., for instance, right? Where the whole of Singapore is actually sleeping, but you're the only ones actually doing work, right? So in the finance industry, this is actually pretty common. Even in glass software, it was pretty common, right? So you come in at 7:30, you knock off at 3 p.m., for instance, right? Because the Japanese market closes at 3, right? So if you have kids and your family, I guess it's a matter of managing their expectations, right? So even in those ungodly hours, even if you don't have any overtime, for instance, of course they're going to complain, right? Right. So it's really just about people-to-people relationships. You need to have an understanding wife, basically, Yeah, you need to have an understanding spouse, or else, I think very difficult, Yeah, I mean, thank God I have an understanding spouse.
That's not the case, from my understanding. That's not the case at most tech companies. I think Luqman is describing examples at specific jobs at banks where you might need to be open at market hours. From the tech companies I've seen, I'm sure 99Co is something like this as well. It keeps relatively normal hours.
It's very laissez-faire. Not very laissez-faire, but there's some structure to it. but we don't expect you to really work long hours unless there's really certain things that you really need to complete before the investor meeting tomorrow, for instance, right? And this is not the norm, basically. And I think I
want to be mindful of time. I know that we are coming over the hour, and unfortunately we have to let people go. Sorry, Luqman, you were in the middle of something. I just cut you off.
Yeah, sorry, but what I'm trying to say is that in the tech industry, right, you actually have a very good advantage. You can actually work anywhere that you want to, as long as you have a laptop, right? And I think that offers a lot of flexibility in and of itself, right? Compared to, for example, you're working menial and manual jobs, for instance, right? Yeah. So that's my takeaway.
Thanks, Luqman. Ray, I hope that answers your question.
Yeah. Thank you.
Okay,
Any questions, just link me up on LinkedIn.
perfect.
Yeah.
Thanks so much.
Okay, great.
Take care, guys.
Bye-bye.
All right.